Welcome to Science, to Sleep By, the place where wonder meets rest. I'm so glad you're here tonight. Together, we'll drift through the stars and let science guide us gently into calm and curiosity. As you settle in, maybe you're lying beneath the faint hum of your bedside light, or listening through your headphones as the world quiets down. Take a deep breath. Let the air move slowly in and out, and feel your mind begin to wander among the stars. Tonight, we're going to explore one of the most breathtaking questions humanity has ever asked. How many galaxies are in our universe? It's a question that stretches across space and time. From the very first spark of the Big Bang to the faintest edge of the cosmic horizon. It's a story of light, distance, and discovery, a story that reminds us just how small and yet how extraordinary we truly are. So, close your eyes if you can, let your body rest, and your imagination float upward past our world, past the moon, beyond the Milky Way, into the boundless ocean of galaxies that surround us. This is Science to Sleep By, and this is our journey through the infinite to discover just how many galaxies exist in the vastness of our universe. When you step outside on a clear night, far from the glow of city lights, the stars spill across the sky like diamonds scattered on velvet. Each one seems so distant, so delicate, and yet together they weave a tapestry that has fascinated humanity since the beginning of consciousness. As your eyes adjust to the darkness, you might notice that some points of light shine more softly than others. Some appear faintly hazy, as though they're veiled behind a cosmic mist. Long ago, before telescopes and satellites, those faint smudges were mysteries. People thought they might be clusters of stars, or perhaps clouds of glowing gas drifting through our own Milky Way. It wasn't until the 20th century that humanity would discover the truth that many of those faint smears of light were not parts of our galaxy at all, but entire galaxies of their own, each containing billions of stars. The universe, as it turns out, is far larger and more populated than anyone could have imagined. The idea of counting galaxies becomes almost humorous when you think about the scale. Imagine trying to count grains of sand on every beach across Earth, then multiplying that number again and again. That still wouldn't come close to the number of galaxies floating in the vastness of space. Yet, as human beings, we can't help but ask. We want to know how big our universe really is, how many worlds might be out there, and where we fit into this grand cosmic story. Astronomy, at its heart, is an act of curiosity born out of darkness. Every star, every galaxy, every faint beam of light that reaches us is a messenger from the past. When you look up at the stars, you're not seeing them as they are now, you're seeing them as they were when that light first left them, thousands, even millions, of years ago. And when astronomers peer deep into the sky using powerful telescopes, they're not just looking farther away, they're looking back in time. The deeper they gaze, the further into the history of the universe they travel. When we talk about galaxies, we're talking about islands of matter, massive systems of stars, planets, gas, dust, and dark matter, all bound together by gravity. Our Milky Way is one such island, a sprawling spiral more than 100,000 light-years across, home to hundreds of billions of stars, and possibly even more planets. But beyond our galaxy, there are countless others, some large and luminous, some small and faint, each with its own shape and story. Some galaxies are spirals like ours, with elegant arms curling outward in soft arcs of starlight. Others are elliptical, shaped like cosmic ovals filled with older, dimmer stars. Then there are irregular galaxies, chaotic and asymmetrical, formed by collisions and cosmic turbulence. To begin understanding how many galaxies exist, we must first grasp what we can actually see. The portion of the universe visible to us is called the observable universe. It's limited not by the size of the cosmos itself, but by the age of light. Since the universe began about 13.8 billion years ago, the farthest light that can reach us has been traveling ever since the dawn of time. Because space itself has been expanding during that time, the diameter of the observable universe isn't 13.8 billion light-years, it's about 93 billion light-years across. Within that sphere lies everything we can possibly detect. Every star, planet, nebula, and galaxy whose light has managed to reach our telescopes. For centuries, people thought the Milky Way was the entire universe. Our understanding of cosmic scale was limited by what we could see with the naked eye. But with the invention of the telescope, we began to uncover more. In the 1920s, astronomer Edwin Hubble observed that faint smudges of light, once thought to be small nebulae within our galaxy, were actually separate galaxies far beyond the Milky Way. That discovery changed everything. Humanity went from believing we lived in a single, self-contained galaxy to realizing that the cosmos was filled with countless others. It was a humbling revelation, a reminder that our place in the universe is not at the center, but among the infinite. When you close your eyes and picture a galaxy, imagine not just a swirl of stars, but a story in motion. Each galaxy is a time capsule, filled with the remnants of its past and the promise of its future. Some contain stars older than our sun, born when the universe was young. Others are nurseries of light, where new stars are still being born from vast clouds of gas and dust. Within those galaxies, countless solar systems may exist, each with their own planets, moons, and perhaps even life. Every one of them, spinning silently in the endless dark, adds to the total number of galaxies we seek to understand. But counting them is no simple task. Even the most advanced telescopes can only see so far, and what they capture is often a mere fraction of the full picture. Imagine shining a flashlight into the ocean at night. You'd see only the water within the beam, while the rest stretches beyond your sight. That's how astronomers study the universe. They take a small patch of sky, observe it deeply, and use that data to estimate how many galaxies might exist across the entire observable universe. One of the most profound discoveries in astronomy came from such an experiment. When scientists pointed the Hubble Space Telescope at a seemingly empty patch of sky in 1995, a spot so small it could be covered by a grain of sand held at arm's length, they expected to find almost nothing. But what came back was astonishing. In that tiny piece of darkness, the telescope revealed nearly 3,000 galaxies, each shining with its own stars and light. That one small observation transformed our understanding of the cosmos. If just one minuscule region of the sky contained thousands of galaxies, then the whole sky, every direction we look, must contain hundreds of billions, perhaps even trillions. Each discovery since has added to that staggering count, reminding us that our universe is far grander than we can easily comprehend. The more we look, the more we realize how incomplete our picture still is. Many galaxies are simply too faint to see, their light stretched by distance and cosmic time until it fades beyond detection. Others may lie hidden behind dust clouds or in regions of space we have yet to explore. Even as our instruments improve, the deeper we peer into the universe, the more we uncover layers of complexity, like peeling back the skin of infinity. When astronomers speak of galaxies, they do so with both precision and poetry. A galaxy isn't just a collection of stars, it's a chapter in the story of the universe itself. From the first small clumps of matter that formed after the Big Bang to the grand spirals and clusters we see today, galaxies have grown, collided, merged, and evolved. They are the architects of cosmic history, the cradles of stars, and the birthplaces of worlds. To understand how many exist is to chase the edges of knowledge itself. Each discovery brings new questions. Are there galaxies beyond what we can ever observe? Almost certainly. Does the number of galaxies have a limit, or is it infinite? We may never know for sure, but within that mystery lies a kind of peace, a recognition that some things are meant to be felt rather than measured. And so, as you listen tonight, perhaps lying in quiet reflection, let your mind drift through that endless ocean of galaxies. Imagine yourself floating in the silent void, surrounded by lights from distant worlds, each one carrying the memory of its creation. The stars, you see, are not alone. They are threads in a vast cosmic fabric that stretches beyond imagination. The universe is not empty, it's alive with galaxies beyond counting, each one a whisper in the grand symphony of existence. Before there were galaxies, before there were stars or planets, before there was even light, there was only energy, pure, formless, concentrated energy held within an infinitesimal point. Then, around 13.8 billion years ago, something extraordinary happened. In a moment that defies human comprehension, that point expanded not into space, but creating space itself. We call that moment the Big Bang, though it was not an explosion in the ordinary sense. It was the sudden stretching of reality, the birth of time, and the beginning of everything we now know as the universe. From that single event, the seeds of all future galaxies were sown, drifting outward into the cosmic darkness that would one day be filled with light. In the very first fractions of a second, the universe was unimaginably hot and dense. Temperatures soared beyond what atoms or even subatomic particles could endure. Matter and energy were almost indistinguishable, existing in a fluid chaos of quarks, photons, and neutrinos, all colliding and transforming in an endless dance of creation and destruction. Space itself was expanding faster than the speed of light, stretching every particle away from every other. Yet, within this wild expansion, patterns were beginning to form, tiny fluctuations in density that would later become the scaffolding for galaxies, stars, and planets. Those minuscule ripples, smaller than a fraction of a hair's width across the vastness of space, were written into the fabric of the cosmos. They were the faint fingerprints of gravity beginning to take shape. As the universe expanded, it cooled. Within a few minutes, conditions had calmed enough for the first atomic nuclei to form. Protons and neutrons began to bond, creating the simplest elements: hydrogen, helium, and a trace of lithium. These were the building blocks from which everything else would eventually emerge. But even then, the universe remained dark. Light could not yet travel freely. It was constantly scattered by the dense fog of charged particles. For nearly 380,000 years, the cosmos was a hot, glowing plasma, shrouded in a haze that hid its newborn form. Then, something remarkable occurred, a moment cosmologists call recombination. As the temperature dropped, electrons began to attach themselves to nuclei, forming neutral atoms. For the first time, it could move unimpeded through space. The universe became transparent, and the first photons were set free. Those ancient photons are still traveling today, stretched by billions of years of cosmic expansion into faint microwaves that fill the sky in every direction. This radiation, known as the cosmic microwave background, is the afterglow of creation, the soft whisper of the universe's first light. It is the oldest light we can see, and it tells us that the universe we observe today was born from something incredibly small, yet infinite in potential. At that stage, there were still no galaxies, no stars, and no planets. The universe was a vast, dark ocean of hydrogen and helium gas. Gravity, though subtle, began to tug at the tiny density variations left over from the Big Bang. Over millions of years, those denser regions pulled in more and more matter, slowly growing into vast clouds. These clouds, under their own gravity, began to collapse, forming the first stars. When those first stars ignited, the universe was bathed in light once more. This was the dawn of the cosmic age of stars and galaxies. Imagine it for a moment: darkness stretching endlessly in every direction, punctuated by the first flickers of starlight. Each one of those first stars was massive, hundreds of times larger than our sun, and burned with a fierce, short-lived brilliance. They forged the first heavy elements in their cores. Elements like carbon, oxygen, and iron, the ingredients of everything familiar to us today. When they died, they exploded in colossal supernova, scattering those elements across space. The gas clouds that followed were enriched by these remnants, giving rise to new generations of stars, and eventually, the first galaxies. Galaxies began as small protogalactic fragments, clusters of gas and stars drawn together by gravity. Over time, they merged and collided, growing larger and more complex. The early universe was a place of chaos and creation, where matter continually clumped, collided, and reorganized into new cosmic structures. From that chaos emerged order patterns that would shape the structure of the cosmos for billions of years. The galaxies we see today are descendants of those early formations, shaped by time, motion, and the relentless pull of gravity. As space continued to expand, these galaxies drifted farther apart, carried along by the stretching fabric of the universe. What began as a small, uniform burst of energy had now become a web of immense beauty, a cosmic tapestry woven from light and darkness. Between galaxies lay vast voids, empty regions where matter was scarce, while along invisible filaments of gravity, clusters of galaxies gathered like pearls on an unseen thread. The universe was not simply expanding, it was evolving, growing in complexity and depth with every passing eon. In the observable universe, everything we see, every star, every galaxy, every distant beam of light traces its origins back to those first moments after the Big Bang. The observable universe is like a cosmic bubble around us, 93 billion light-years wide, filled with everything that light has had time to reach us from. Beyond that horizon may lie more galaxies, more stars, perhaps even other cosmic regions we can never see, forever hidden by the limits of time and light. What we call the observable universe is not the boundary of existence, it is simply the limit of what we can know. From our perspective here on Earth, peering through telescopes and instruments, we are looking backward in time. When astronomers observe distant galaxies, they are seeing them not as they are now, but as they were billions of years ago. The light that reaches us today began its journey long before our planet even existed. In this way, the universe is like a time machine, allowing us to witness the stages of its own creation frozen in light. The further we look, the younger the universe appears, until, at the farthest reaches, we approach its very birth. The birth of the observable universe is not just a story of physics and energy, it is the beginning of everything we understand, everything that will ever be observed, imagined, or dreamed. It marks the moment when chaos began to organize into form, when the seeds of galaxies were planted in the dark soil of space. Even now, billions of years later, that story continues to unfold. The same forces that shaped the early universe are still at work today, pulling galaxies together, driving others apart, sculpting the cosmic web that stretches across all of existence. When we study this origin, we are also studying ourselves. Every atom in your body, every breath you take, every heartbeat, is made of material forged in those early stars, atoms born from hydrogen and helium that trace their lineage to the first moments of the universe. You are, in a very real sense, a child of the Big Bang, a fragment of stardust shaped by cosmic history. The observable universe is not something distant and detached, it is the very fabric from which you are made. In the calm of the night, when you gaze at the stars, you are looking into a story that began long before humanity existed. The light that reaches your eyes may have begun its journey when the first galaxies were still young, somewhere at the edge of what we can see. That story continues in silence, a story of birth, light, and endless expansion. Written in ancient language of the cosmos in the early 1990s, a telescope orbiting high above Earth began to change the way humanity looked at the cosmos. The Hubble Space Telescope, named after the astronomer Edwin Hubble, had already shown us worlds and wonders never before seen. Swirling nebulae, spiraling galaxies, and the delicate structure of starlight stretched across unimaginable distances. Yet one of its greatest discoveries came not from what it saw immediately, but from what it dared to look for in the emptiest part of the sky. This is the story of how one telescope pointed at what seemed to be nothing and revealed nearly everything. Imagine, for a moment, a patch of sky so small it could be covered by a grain of sand held at arm's length. A region near the Big Dipper, unremarkable and dark, appearing utterly blank to the naked eye. Astronomers decided to aim Hubble at that tiny, seemingly empty space, and let it collect light for days. This was a bold decision. Telescope time is precious, and pointing one of the world's most powerful instruments at nothing felt like a gamble. But that gamble would change our perception of the universe forever. Over the course of 10 continuous days in December 1995, Hubble observed that patch of sky for more than 100 hours. Gathering faint light from the distant cosmos, the image that returned was astonishing. What had once looked empty was now teeming with galaxies, nearly 3,000 of them, each one unique, each one representing a vast island of stars, planets, and cosmic history. Some were spiral, others elliptical, some faint smudges of light from billions of light years away. That single image, known as the Hubble Deep Field, transformed our understanding of the universe. It showed us, in exquisite detail, that the night sky is not a void, but a tapestry of light, stretching endlessly across time and space. Every dark region, no matter how small, contains countless galaxies beyond what we can see. That realization was both humbling and awe-inspiring. It revealed that the universe is far denser with galaxies than anyone had dared imagine. The deep field became a window not just into space, but into the past, because every galaxy captured in that image was seen as it existed billions of years ago. Their light had been traveling since near the dawn of time, crossing cosmic distances to finally reach the lens of a telescope orbiting Earth. What makes the Hubble Deep Field so remarkable is that it condensed the immensity of the cosmos into something the human eye could see. When astronomers looked at that image, they weren't just seeing galaxies. They were seeing history, each one frozen in a different era of the universe's life. Some of those galaxies existed when the universe was only a fraction of its current age. Others formed later, after billions of years of evolution. Together, they told a story that stretched back to the very beginning, showing us the universe as it grew and changed across cosmic time. The faintest galaxies in that image were more than 12 billion light-years away. Their light began its journey when the first galaxies were just forming, when stars were still assembling from clouds of primordial gas. These ancient beacons are relics of the early universe, silent messengers carrying information from a time long before our planet existed. Every photon captured in the Hubble Deep Field had traveled across the expanding fabric of space for billions of years, dodging dust, drifting through voids, bending around massive objects through the gentle warping of gravity, until it finally reached Hubble's sensors. Each pixel in that image was a whisper from the past. When scientists analyzed the deep field, they realized that if such a small portion of the sky contained thousands of galaxies, then the entire sky must contain hundreds of billions, perhaps even more. Later observations and improved instruments would confirm that number to be in the hundreds of billions. And later estimates from the Hubble Ultra Deep Field and the Hubble Extreme Deep Field suggested the total number of galaxies in the observable universe might exceed 2 trillion. It's a number so large that it nearly loses meaning, but what it represents is profound. It means that every point of darkness we see above us is not empty. It is alive with light too faint for our eyes to perceive. The Hubble Deep Field wasn't just an image. It was a revelation. It showed that the universe is filled with galaxies of all shapes, sizes, and ages. Some are massive spirals with bright cores, while others are small, irregular, and dim remnants of the early days of cosmic formation. It demonstrated that galaxies are not evenly spread through space, but clumped together in vast structures, separated by immense cosmic voids. These patterns told astronomers something crucial about the underlying fabric of the cosmos, that it is shaped by gravity, dark matter, and dark energy working together to sculpt the universe we see today. But the beauty of the Hubble Deep Field extends beyond science. It carries a sense of wonder that reaches deep into the human spirit. Looking at that image, people around the world felt something both intimate and infinite, a sense that our tiny world, orbiting a modest star in one corner of a single galaxy, is part of something far larger and grander than we could ever imagine. For scientists, it became a roadmap for future exploration. For dreamers, it became a symbol of cosmic perspective. The story didn't end there. Encouraged by the success of the first deep field, astronomers conducted new, deeper observations. The Hubble Ultra Deep Field, taken in 2003 and 2004, revealed more than 10,000 galaxies in a patch of sky even smaller than the original. Later, the Hubble Extreme Deep Field, created in 2012 by combining over a decade of data, pushed our view of the universe even further back, nearly to the first generation of galaxies. These later images showed galaxies so faint and distant that their light had been stretched into infrared wavelengths by the expansion of the universe. Each new deep field peeled back another layer of cosmic history, taking us closer to the beginning of everything. The Hubble Deep Field also helped pave the way for the next generation of telescopes, like the James Webb Space Telescope. Webb's infrared vision allows it to see even further, detecting galaxies from just a few 100 million years after the Big Bang. Together, Hubble and Webb tell a continuous story of cosmic evolution, from the first flickers of light to the grand structures we see today. Every discovery builds upon the last, each one bringing us closer to understanding how our universe grew from simplicity to the complex beauty we observe now. It's easy to forget that the deep field began with what appeared to be nothing. The image is a reminder that emptiness is often an illusion. What seems invisible may simply be beyond the limits of our vision. The universe hides its treasures in darkness, waiting for us to look deeper, to see beyond the obvious. The Hubble Deep Field teaches us that patience and curiosity can turn even the smallest, quietest corner of the cosmos into a window to infinity. When you think of that image, thousands of galaxies shining in a patch of sky no larger than a pinpoint, it's almost overwhelming. Each galaxy may contain hundreds of billions of stars, and each of those stars may host planets. Some, perhaps like Earth. Every point of light in that photograph could hold its own stories, its own suns, its own possible lives, looking back into their night skies and wondering if they too are alone. It is the ultimate reminder that we are part of something boundless, a universe where every speck of darkness may conceal endless light. The Hubble Deep Field remains one of humanity's most profound scientific and spiritual achievements. It bridges the gap between knowledge and wonder, between data and imagination. It captures the infinite in a single frame, reminding us that the universe is not a distant abstraction, but a living, breathing expanse of time and light, woven together by the same physics that created us. And though it may appear still and silent, that image represents a universe in motion. Galaxies colliding, stars being born, and light traveling endlessly across the vast, expanding ocean of space. When scientists first began to understand that our Milky Way was not the entire universe, but just one of many galaxies scattered across space, they were confronted with the question that was as humbling as it was enormous. How many galaxies are there? It sounds simple, yet it is one of the most profound questions astronomy has ever faced. To answer it means to measure the scale of everything that exists, to trace the universe's architecture from the smallest clusters of stars to the farthest reaches of the observable cosmos. And to do that, humanity has had to combine imagination, technology, and time itself into a single act of discovery. Early in the 20th century, after Edwin Hubble's breakthrough that revealed other galaxies beyond the Milky Way, astronomers began to grasp the immensity of space. At first, estimates of the total number of galaxies were modest by today's standards. In the mid-1900s, with optical telescopes limited by Earth's atmosphere, scientists could observe only the brighter, larger galaxies. Their early counts suggested there might be tens of millions of galaxies within the observable universe, a staggering number for its time. Yet even then, it was clear that our view of the cosmos was just beginning to sharpen, and those early estimates were only the first steps toward understanding the true scale of existence. With the launch of space-based telescopes like Hubble, our ability to see deeper into the universe expanded dramatically. Freed from the blurring effects of Earth's atmosphere, Hubble could peer far beyond what ground-based telescopes could ever reach. It became a cosmic census taker, capturing images of the distant universe with stunning clarity. The Hubble Deep Field, which revealed thousands of galaxies in a patch of sky that appeared empty, changed everything. When astronomers multiplied that density of galaxies across the entire sky, they arrived at an early estimate of around 100 to 200 billion galaxies in the observable universe. For years, that number became the accepted figure, a benchmark of cosmic scale, an almost unfathomable count of galactic worlds. But science, like the universe itself, keeps expanding. As technology improved, astronomers realized that even Hubble's deep observations might only be showing the brightest galaxies, those whose light could still reach us after billions of years of cosmic dimming. there could be many more galaxies, too faint or too small to detect, hidden beyond the limits of Hubble's sensitivity. By using mathematical modeling, computer simulations, and data from ever deeper surveys, researchers began to suspect that the true number of galaxies was far greater than the 200 billion once believed. In 2016, a groundbreaking study led by Christopher Consolis of the University of Nottingham used advanced modeling techniques to estimate that the universe could contain as many as 2 trillion galaxies, 10 times more than earlier estimates. This conclusion came from combining data collected over decades with theoretical models that accounted for galaxies too faint or distant to be detected directly. If that number is accurate, it means that for every galaxy we can currently observe, there could be 9 more hidden in the dark, waiting for future telescopes to reveal them. The process of estimating how many galaxies exist involves both observation and inference. Astronomers take deep-field images of small sections of the sky, count the number of galaxies they can see, and then extrapolate those numbers across the full dome of the heavens. The observable universe is roughly spherical and has a radius of about 46.5 billion light-years in every direction. By multiplying the density of galaxies found in small observed regions by the total volume of that space, scientists can estimate the cosmic population. But this method relies on assumptions, for example, that the distribution of galaxies is roughly uniform across the universe, and that no major regions remain unseen or undercounted. As our tools grow more sensitive, those assumptions are constantly refined. Some regions of the universe are denser than others. Galaxies tend to cluster along filaments of dark matter, leaving vast cosmic voids between them. The observable universe resembles a vast web, with galaxies strung together like jewels on invisible threads of gravity. Within those threads, galaxies can appear in groups, clusters, or superclusters, some stretching across hundreds of millions of light years. So when astronomers estimate the number of galaxies, they are not just counting. They are mapping the structure of the entire cosmos, tracing the patterns that gravity and dark energy have woven through time. The challenge is compounded by the limits of light itself. Many galaxies are so distant that their light has been redshifted far into the infrared spectrum, stretched by the expansion of the universe until it slips beyond the range of visible detection. Others are faint because they are small or because their light has been dimmed by dust and interstellar matter. Even our most powerful instruments can only detect a portion of them. What we see, then, is a partial universe, a cosmic sample that hints at what lies beyond our observational reach. The James Webb Space Telescope, launched in 2021, has begun to reveal some of those hidden galaxies. Its infrared vision allows it to detect the faint light from galaxies that formed only a few 100 million years after the Big Bang. Webb's early data has already revealed galaxies that appear older and more massive than expected, forcing astronomers to reconsider how quickly the universe built its structures. With every new observation, our count of galaxies becomes both more refined and more mysterious. Each discovery deepens the question, rather than answering it fully. Even with these advances, it's important to remember that the observable universe is only a fraction of the whole. The universe extends far beyond the limits of what we can see, possibly infinitely far. The galaxies we can detect are those whose light has had time to reach us in the 13.8 billion years since the Big Bang. Beyond that horizon may lie countless others, hidden by distance and time, unreachable forever. So when we speak of the number of galaxies in the universe, we are really speaking of the number within our cosmic bubble, the visible portion of reality that our instruments can measure. The total unobservable universe may contain an even greater, possibly endless number of galaxies, a concept that stretches imagination itself. Estimating the galactic population is more than just counting. It is about understanding the processes that create and sustain galaxies. Galaxies form from the collapse of gas and dark matter under gravity, and their growth depends on interactions, mergers, and cosmic feedback from stars and black holes. The distribution of galaxies reveals how matter is organized on the largest scales, offering clues about the forces that govern the universe. By mapping their abundance and motion, astronomers can infer the amount of dark matter and dark energy, the invisible components that make up most of the cosmos. Each galaxy is a clue in a grand cosmic puzzle, and the total number helps shape our understanding of how the universe evolves. When you think about 2 trillion galaxies, it's easy for the mind to go numb. Numbers that large cease to feel real. But try to picture it this way. If each galaxy contains around 100 billion stars, then 2 trillion galaxies would mean roughly 200 sextillion stars. That's a 2 followed by 23 zeros. Many of those stars may host planets, and some of those planets could be habitable. The sheer scale suggests that the universe is bursting with possibility, that life could exist in forms and places we can scarcely imagine. What began as an attempt to count galaxies becomes, in a deeper sense, a meditation on existence itself. The act of counting the galaxies is also an act of looking back in time. Every distant galaxy we see is not how it looks now, but how it appeared billions of years ago when its light began the journey toward us. The farther away it is, the older its light. So our census of the universe is also a history book, recording how galaxies have evolved from small, clumpy structures in the early universe to the majestic spirals and ellipticals we see nearby. It's a story of birth and transformation, of stars forming, dying, and being reborn in endless cycles of creation. In this way, estimating the number of galaxies becomes more than an exercise in astronomy. It becomes a reflection of our own curiosity, our desire to measure what cannot be measured, to grasp what may forever lie beyond our reach. It shows that even as our instruments grow more powerful, the universe always stays one step ahead, revealing just enough to keep us wondering. The number of galaxies may continue to change as we learn more, but the feeling it evokes, that quiet awe at the immensity of everything, remains the same. Every count, every estimate, every observation reminds us that we live in a universe vast beyond imagining, filled with billions upon billions of cosmic islands drifting in the dark, each one carrying its own stars, its own stories, its own version of the infinitesimal night sky, as deep and infinite as it seems, is only a faint reflection of the universe's true magnitude. What we see through telescopes, even with the most powerful instruments ever built, is just the surface of an unfathomable ocean. Beneath that visible layer lies a hidden cosmos, galaxies so faint, so distant, or so ancient that their light has never reached us. They drift silently beyond the edge of detection, existing in realms where light is stretched thin by time and space, far beyond what our eyes or machines can yet perceive. To understand these unseen galaxies is to recognize that much of the universe remains invisible, concealed not by distance alone, but by the limits of human perception itself. When astronomers gaze deep into the night, they are not simply looking into space, they are looking back in time. Every ray of light that reaches a telescope has traveled for billions of years across the expanding universe. The further we look, the older the light becomes, until eventually it reaches an age when galaxies were first beginning to form. But there is a boundary to that vision, a point where light has been stretched and weakened so much by the expansion of space that it can no longer be detected. Beyond that boundary lies a realm of galaxies that exist, but remain unseen, not because they are gone, but because their light has yet to reach us, or has grown too faint to be captured. These invisible galaxies form a kind of cosmic shadow, a counterpart to the luminous universe we can observe. Astronomers know they are there, even if they cannot be seen directly, because of the subtle traces they leave behind. Gravity, the silent architect of the cosmos, gives away their presence. Through its pull, it shapes the motions of visible galaxies, bends the paths of light from more distant ones, and reveals the existence of mass hidden in the dark. This effect, known as gravitational lensing, acts like a natural telescope. When light from a faraway galaxy passes near a massive object such as a galaxy cluster, gravity bends that light, magnifying and distorting the image. Sometimes, this lensing allows us to glimpse galaxies that would otherwise be invisible, their faint glow magnified by cosmic geometry. It is through this delicate dance of gravity and light that we've begun to sense the presence of the unseen universe, Yet not all galaxies are hidden by distance alone. Some are cloaked by dust and gas, their light absorbed and ray emitted in wavelengths that ordinary optical telescopes cannot detect. These dusty galaxies, often found in the early universe, are rich in star formation, cosmic nurseries where new stars are born at astonishing rates. Their brilliance is shrouded in veils of interstellar dust, rendering them nearly invisible in visible light. But when viewed through infrared telescopes, like the James Webb Space Telescope, these galaxies emerge as glowing embers, their heat betraying their hidden activity. In this way, modern astronomy has begun peeling back layers of cosmic obscurity, revealing galaxies that were once completely unknown. The concept of unseen galaxies also extends to the smallest structures in the universe, faint dwarf galaxies that orbit larger ones like silent companions. These tiny galaxies are difficult to detect because they emit very little light, yet they may outnumber the brighter galaxies we see. Around the Milky Way alone, astronomers have discovered dozens of such faint satellites, and simulations suggest there could be hundreds more. They are relics of the early universe, fragments left over from the assembly of larger galaxies. Studying them provides a glimpse into how galaxies grow and evolve over billions of years. Even within our cosmic neighborhood, the universe hides secrets in plain sight. Concealed by their faintness and our limited reach, the faintest galaxies also play a crucial role in understanding cosmic history. In the early universe, small, dim galaxies were the engines of a transformative event known as reionization, the period when the first stars and galaxies relit the universe after the long darkness that followed the Big Bang. Their light, though faint, gradually ionized the hydrogen that filled space, allowing light to travel freely for the first time. Without these countless small galaxies, the universe might have remained shrouded in fog. But because they are so distant and faint, most of them remain undetected, their contribution inferred rather than observed. The James Webb Telescope's ability to see in the infrared has begun to uncover some of these galaxies, revealing that the early cosmos was far busier and more luminous than we once believed. Beyond these faint and dusty galaxies lies another realm of invisibility. The galaxies hidden not by light, but by physics itself. Some regions of the universe are moving away from us faster than light can travel, carried outward by the expansion of space. Their light, no matter how bright, will never reach us. They exist forever beyond our horizon, reachable and unknowable. As the universe continues to expand, more galaxies will slip beyond this boundary, their light stretched into infinity. Over billions of years, the observable universe will grow quieter as distant galaxies fade from view, leaving only the local group, the Milky Way, Andromeda, and their companions bound together in an island of gravity adrift in the cosmic dark. Astronomers also suspect the existence of galaxies made primarily of dark matter, containing few stars or none at all. These dark galaxies would be nearly invisible, detectable only through their gravitational influence. Though still theoretical, some observations hint at their existence. When scientists map the motions of galaxies within clusters, they often find discrepancies, movements that suggest the presence of unseen mass. Computer simulations of the universe's evolution predict that dark matter is the framework upon which all galaxies form. If that's true, then there may be entire galaxies made almost entirely of this mysterious substance. Faint shadows in the cosmic web, ghostly structures that give shape to the visible universe. The challenge of detecting unseen galaxies pushes astronomy into the realm of the invisible. Observatories that can detect radio waves, X-rays, and infrared radiation each open new windows into the dark. The Atacama Large Millimeter Array in Chile, for instance, can see cold gas in distant galaxies that optical telescopes miss, while instruments like the Chandra X-ray Observatory detect the high-energy glow from black holes at the centers of galaxies billions of light-years away. Together, these observatories reveal a universe that is far richer and more complex than what light alone can show. Even with these tools, the unseen galaxies remind us that our understanding of the cosmos is partial. We are creatures of light, dependent on photons to sense our surroundings. Yet most of the universe does not shine. It exists in silence, its presence betrayed only by its influence. This limitation is both humbling and inspiring. It means there is still so much left to discover, a vast hidden cosmos that challenges the boundaries of observation and imagination alike. When we look up at the stars and think of galaxies, we picture brilliant spirals, bright clusters, and glowing nebulae. But for every one that shines, there are countless others that remain unseen, their light swallowed by time, dust, or distance. They drift through the deep voids between clusters, faint echoes of creation, whispering stories that have yet to be heard. They remind us that even in the age of advanced telescopes and space exploration, we are still exploring the surface of an infinite mystery. The unseen galaxies are not lost to us. They are part of the grand continuum of discovery, waiting for the next generation of eyes to uncover them. As technology evolves, as telescopes become larger and sensors more sensitive, the boundary of the visible universe will continue to expand. What lies beyond that edge today may one day be revealed, and beyond that, more will still remain hidden, stretching endlessly into the unknown, a cosmic reminder that the universe will always hold more than we can see when we gaze into the deep night sky. It's tempting to believe that we are seeing most of what exists, that the dazzling field of stars and galaxies captured by telescopes represents the total cosmic picture. Yet, the truth is far more staggering. Counting galaxies is not like counting stars in a single region of the Milky Way. It is a task so vast that it challenges our most advanced technology and our most sophisticated theories. To count galaxies is to attempt to measure the universe itself, an ocean of unimaginable scale, whose depths extend beyond the reach of light, beyond time, and perhaps beyond comprehension. For most of human history, the universe was believed to consist of just our galaxy, the Milky Way. That perception changed dramatically in the 1920s, when Edwin Hubble, using the powerful Hooker telescope at Mount Wilson Observatory, made a revolutionary discovery. He observed faint, fuzzy objects in the sky that astronomers called nebulae. By measuring their light, Hubble realized that these were not gas clouds within our galaxy, but entire galaxies themselves, vast and distant systems of billions of stars. That moment transformed our understanding of the cosmos. The Milky Way was no longer the entire universe. It was merely one among countless others. But how many others? That question became one of the central mysteries of astronomy. In the mid-20th century, astronomers began photographing the night sky with more powerful telescopes, identifying thousands, then millions of galaxies. Each new survey seemed to reveal more than the last, suggesting that the universe might contain an almost infinite number of them. Yet even those estimates were limited by the sensitivity of the instruments used. The deeper we looked, the more galaxies we found. As if the cosmos had no end to its complexity or depth, the most profound leap in our understanding came in the 1990s, when the Hubble Space Telescope turned its gaze toward a tiny, seemingly empty patch of sky near the Big Dipper. Over a period of 10 days, it collected faint light from that small region, creating an image known as the Hubble Deep Field. What astronomers saw stunned the world. That single, dark patch smaller than a grain of sand held at arm's length contained nearly 3,000 galaxies. Some were large and bright, while others were faint smudges of ancient light, their glow traveling for billions of years before reaching us. This experiment suggested that if such a small region of sky could contain thousands of galaxies, then the entire observable universe must contain hundreds of billions, perhaps even trillions. Later observations, such as the Hubble Ultra Deep Field and its successor, the Hubble Extreme Deep Field, pushed these limits even further. These surveys looked deeper than ever before, capturing light from galaxies so distant that they existed when the universe was less than 1 billion years old. By extrapolating from these deep field images, astronomers initially estimated that the observable universe contained around 100 to 200 billion galaxies. However, this was only a starting point, limited by the capabilities of the instruments and the wavelengths of light they could detect. As technology advanced, particularly with the launch of the James Webb Space Telescope JUICE. Those numbers began to change dramatically. Webb, designed to observe in infrared light, can see objects that are too faint or too distant for Hubble to detect. Infrared light reveals galaxies that are obscured by dust or whose light has been stretched by cosmic expansion. In its first months of operation, JUICE identified galaxies that existed just a few 100 million years after the Big Bang, some of the earliest and faintest galaxies ever seen. These discoveries suggested that the early universe was far more populated than scientists once believed, filled with countless small, faint galaxies that never appeared in Hubble's view. With these new observations, astronomers began to rethink their calculations. Studies analyzing the faint background glow of the universe, the cumulative light from all distant galaxies, suggested that many galaxies are too faint to be detected even by the most sensitive telescopes. Using computer models, scientists inferred that for every bright, visible galaxy, there might be dozens of faint ones hiding beyond the threshold of detection. This led to a revised estimate: the observable universe could contain as many as 2 trillion galaxies. Each of these galaxies might contain anywhere from a few million to several trillion stars, each star potentially surrounded by its own planets, moons, and systems. The sheer scale of this cosmic population is beyond comprehension. A universe not merely large, but overwhelmingly abundant. Counting galaxies, however, is not as simple as tallying visible dots on a cosmic map. The universe is expanding, and as it does, light from distant galaxies becomes redshifted, stretched into longer wavelengths, making them fainter and harder to detect. Some galaxies are so distant that their light has not yet reached us, while others are hidden behind interstellar dust or absorbed by intervening gas clouds. Even with advanced telescopes, astronomers must rely on statistical models and extrapolations to estimate how many galaxies exist beyond what we can observe. It's like trying to count all the fish in the ocean. By looking through a small porthole, you can only see a fraction, but patterns and probabilities help fill in the rest. Moreover, not all galaxies are equally bright. Many of the universe's galaxies are small and faint, composed of only a few million stars far dimmer than the Milky Way or Andromeda. These dwarf galaxies are often lost in the cosmic background, detectable only through subtle gravitational effects or through their interaction with nearby galaxies. Their abundance makes them crucial to understanding the large-scale structure of the universe, as they represent the building blocks from which larger galaxies form through mergers and accretion. In essence, the faintest galaxies are the fossils of cosmic evolution, remnants of the first star-forming systems that illuminated the universe after its long dark age. To refine these estimates, astronomers use data from large-scale surveys such as the Sloan Digital Sky Survey (CDS) and upcoming missions like the Vera C. Rubin Observatory's Legacy Survey of Space and Time (LEST). These projects map vast portions of the sky in multiple wavelengths, cataloging billions of galaxies and measuring their distances. Combined with data from space-based observatories like Hubble, Webb, and the upcoming Nancy Grace Roman Space Telescope, these surveys allow scientists to create three-dimensional maps of the universe, tracing how galaxies are distributed across cosmic time. Through these efforts, the universe reveals itself not as a random scattering of galaxies, but as an intricate web of filaments, clusters, and voids, a grand structure sculpted by gravity and dark matter. The effort to count galaxies also deepens our understanding of cosmic evolution. By comparing the number and distribution of galaxies at different distances, and therefore different ages, astronomers can reconstruct how the universe has changed over billions of years. The early universe, for instance, appears to have been packed with small, irregular galaxies that gradually merged to form the massive spirals and ellipticals we see today. In this way, counting galaxies becomes a means of tracing the universe's life story, a cosmic census that reveals how matter, energy, and structure have evolved since the dawn of time. Still, it's important to recognize that all these numbers, billions, trillions, refer only to the observable universe. the portion of space from which light has had time to reach us since the Big Bang. The actual universe may be much larger, perhaps infinitely so. If the cosmos extends beyond what we can see, then there could be countless more galaxies existing in regions forever beyond our reach. Our estimates, astonishing as they are, might represent only a small fraction of the true total. Even so, the attempt to count galaxies carries profound philosophical weight. It reminds us of how small we are in the grand scheme of existence. The Milky Way, with its 200 billion stars and countless planets, is but a single grain in a beach of cosmic sand that stretches beyond imagination. Every galaxy is its own island universe, containing billions of suns and perhaps billions of worlds. Somewhere within that cosmic multitude, other forms of life may exist. Other civilizations may gaze at their skies and wonder the same question: how many galaxies are there in the universe? The act of counting, then, is not just a scientific pursuit, but a human one, an expression of our innate desire to understand the infinite. Each time we build a more powerful telescope, each time we peer deeper into the dark, we uncover new layers of reality, each revealing that the cosmos is vaster and richer than we ever dreamed. The universe is not a static collection of stars, but a living expanse of creation, still unfolding, still revealing its secrets, still defying our efforts to define its limits. When astronomers talk about the observable universe, they refer to a cosmic bubble stretching roughly 93 billion light-years across, filled with everything we can possibly detect: galaxies, stars, clusters, and the faint glow of the cosmic microwave background. It's a boundary defined not by physical walls, but by time and the speed of light. Beyond that horizon lies a realm we cannot see, a realm that stretches into mystery. The observable universe is only a fragment of something far greater, and what exists beyond it may be infinite in scale, timeless in depth, and filled with countless galaxies that will never appear in any telescope, no matter how advanced. To look beyond the observable is to confront the question of infinity itself, the question of whether existence has an edge, or whether it extends forever into the dark. To grasp the idea of what lies beyond, one must first understand why there is a limit at all. The speed of light, though unimaginably fast, is not instantaneous. Light travels at about 186,000 miles per second, but even at that speed, it takes time to cross the cosmic distances between galaxies. Since the universe is about 13.8 billion years old, one might think that we can see light from objects up to 13.8 billion light-years away. But because space itself has been expanding during that time, the light we see from the farthest galaxies was emitted when they were much closer, and the space between us has stretched as that light traveled. Today, those galaxies are now roughly 46 billion light-years away in every direction, defining the radius of the observable universe. Beyond that distance, light hasn't had enough time to reach us since the beginning of time, yet the expansion of space continues relentlessly, carrying distant galaxies ever farther away. The universe is not static but dynamic, its fabric stretching like a balloon being inflated. Our ability to count galaxies, to map their light, to measure their distances, is more than an achievement of science. It is a testament to the human spirit. From the earliest astronomers who charted the constellations by torchlight to the engineers who designed space telescopes orbiting above Earth, humanity has carried an unbroken lineage of curiosity. That curiosity has taken us from myths of the heavens to measurements of cosmic expansion, from the invention of telescopes to the detection of galaxies forming at the dawn of time. Each discovery brings us closer, not to the edge of the universe, but to a deeper understanding of our place within it. And still, there is so much we do not know. We have barely mapped a fraction of the galaxies that exist. We have not seen what lies beyond the cosmic horizon. We do not yet understand the true nature of dark matter, or the mysterious force of dark energy that drives the universe's expansion. Every answer raises new questions. Every revelation opens another layer of mystery. The cosmos continues to unfold, inviting us to explore, to learn, to wonder. As we look out across the galaxies, we are reminded that the universe is not static. It is alive with motion, transformation, and creation. Galaxies collide and merge, stars are born and die, new elements form in the crucible of stellar cores. Even our own Milky Way is moving on a slow, inevitable collision course with the Andromeda Galaxy. In about 4 billion years, the two will merge into a single, giant elliptical galaxy. Long after humanity is gone, the legacy of our galaxy will continue, reshaped by the same cosmic forces that have governed the universe since its beginning. Humanity's place among the galaxies is both small and vast. Small, because we occupy a tiny corner of an incomprehensible universe. Vast, because through our awareness, the universe has found a voice. The galaxies may stretch endlessly into the dark, but from our tiny planet, we have begun to give meaning to that darkness. Every discovery, every image of distant light, every whisper from the depths of space adds another brushstroke to the grand cosmic story. A story in which we, however, briefly, have the privilege to participate. Conclusion of the entire script. How many galaxies are in our universe? Science to sleep by as we reach the quiet end of our journey through the cosmos. Let your mind drift one last time among the stars. The question that began this voyage, how many galaxies are in our universe, is one that cannot be answered with precision, but rather with awe. 2 trillion galaxies, maybe more, fill the observable universe, each containing billions of suns, each a vast system of its own. But beyond what we can observe lies even more regions forever hidden from view, where light has not yet reached us. The true number of galaxies may be infinite, stretching beyond time, beyond distance, beyond comprehension. What we have learned is that every galaxy is a story, a collection of stars born, living, and dying over billions of years. Every point of light we see in the night sky is a message from the past, a spark of creation that traveled across unimaginable distances to find us here. And in those distant lights, we see echoes of our own origins, reminders that the same forces shaping the galaxies also shaped us. We live in one galaxy among trillions, on one planet among countless worlds, orbiting one star among billions. Yet somehow, against all odds, we have become aware of it. We have looked out into the infinite and found beauty, mystery, and belonging. The galaxies remind us that our smallness does not diminish our worth. It magnifies the miracle of our existence. So tonight, as you rest, let your thoughts expand beyond the horizon of the known universe. Imagine the stars swirling in distant spirals, the soft glow of newborn galaxies forming at the edge of time, the endless dance of light and gravity weaving the cosmic web together. Let it bring you peace, knowing that you are a part of that grand design, a fleeting, conscious moment in an eternal sea of galaxies. This is the gift of science and wonder, to remind us that even in the vastness of the cosmos, we are never truly lost. We are the universe made aware of itself, gazing back across time and space with gentle curiosity. And as your eyes grow heavy and your breathing slows, remember somewhere out there, countless galaxies shine silently in the dark, and their light is finding its way to you, carrying the quiet hum of the universe itself. Good night, dreamer of the stars. This has been Science to Sleep By.